Welcome back, everyone. We're now going to be doing question 5 in your handy dandy packet. So get out that packet and let's get going. So again, if you look at the picture, which I know I haven't even talked about the problem yet, but if you look at the picture, it kind of looks like some similar triangles going on. We have this smaller triangle right here, and we have this larger triangle. So after we kind of set this up, this is going to be very similar to when we were solving for the sides of similar triangles. So hopefully after we get it set up, it will be very familiar to what we've been doing. Okay, so this is actually when similar triangles are used quite a bit in the real world. When you use something other than actually measuring something, this is called indirect measurement. Okay, so it says to estimate the height of a pole. So we're trying to estimate the height of the pole using a comparison to someone else or something else. Okay, so we are going to be predicting the height of this pole using similar triangles or using the height of this basketball player. Okay, so since we are actually not measuring the height of the pole, this is called indirect measurement. We're finding the height. We're measuring the height of the pole in a different way other than literally measuring it. Okay, so this is actually used a lot in the real world to find either different distances that are hard to measure or different heights. Okay, so let's get going. So to estimate the height of a pole, which in my picture, which you guys should have this picture, I wrote on there, this is the pole. A basketball player exactly 2 meters tall stood so that the end of his shadow and the end of the pole shadow coincided. Okay, so here's our little basketball player dude. It said in the problem that his height is 2 meters tall. So he probably lives somewhere else in the world other than the US because they're using meters to measure the height of the basketball player. So this is probably like, you know, European or Australian or African or Asian dude. Alright, so someone from a different country because typically in the US we don't measure in meters. But, you know, maybe they were. I guess I don't really know. They could be from the US. But, you know. Alright, so the height of our basketball player is 2 meters tall. Okay. And it says that he stood so that the end of his shadow and the end of the pole shadow coincided. So if you guys see, here's the sun. The sun rays are hitting the top of the basketball player. All right, and then a shadow is created on the floor. Okay, so this is the shadow of the basketball player. And then the shadow of the pole is this entire thing. So just be careful. This is the shadow of the basketball player. The shadow of the pole starts from here and ends here. Okay, so we know that the shadow of the basketball player and the pole's shadow ends right here. Okay? Now, it says that he found that DE and FE measured 1.6 meters and 4.4 meters respectively. So that means they go in the order that they're listed in. So DE, since DE was listed first, 1.6 is listed first. So DE is 1.6 meters. And FE is 4.4 meters. So this is 4.4. Okay, so this is the basketball player's shadow. Goes from here to here. Now the pole shadow starts here and ends here. Okay, so we have to be careful. And I should have been doing this in different colors, you guys. I don't like to do things in the same colors. Okay, so if I would have rethought this problem, this is how I would have done it. Sorry, guys. Okay, so this 4.4 meters is not the pole's shadow, so you have to be careful. That is just the distance from the pole to the basketball player. Okay, so the shadow of the pole is this whole thing. Okay, and then we want to know how tall was the pole. So I don't know the pole's height, so I'm going to put X. I don't know. This is the height of the basketball player. Okay, so if you guys see, there's a lot going on in this problem. We have a little triangle and we have a big triangle. Okay, so sometimes it helps to separate the two triangles so you can visualize it better. I'm going to show you how to do this on this triangle as well as our two separate triangles so you can kind of pick which way you like to do it. Okay, so here's I'm going to go ahead and do the basketball player's triangle because I already know all the information. I know the distance from the basketball player to the end of the basketball player's shadow is 1.6 meters. So this is the shadow, again, and it's 1.6 meters. Okay, and then this is going to be the height of the basketball player. So the height of the basketball player is 2 meters. Okay, now the pole. This is where it gets tricky. Currently, I don't know the height of the pole. That's why I made it an X. Okay, now the shadow is this entire distance. It's not just FE. FE is the distance from the pole to the basketball player. So if I know FE is 4.4 and ED is 1.6, how do I find the length of the entire shadow, which is FE and ED combined? Holy hot dog, you guys, you do add them together. So if I add these two parts together, I will get the entire shadow, which 4.4 plus 1.6 gives me 6 meters. So I know the whole shadow of the pole is 6 meters. So this is the shadow for the pole. So again, you can either label it on this picture or on your separate picture, you can call this the shadow of the pole. So the shadow of the pole is 6 meters. Okay, and now don't forget, all we have to do is set up a proportion, which when we do this, we want to make sure we put the same spots or the same objects in the same places of my fraction. So it doesn't matter if we start with the height or the shadow. I'm just going to start with the height. So I'm going to put the height in the numerator. Height. And I'm going to put the shadow length in the denominator. So this is the shadow. Okay. So I'm going to start, it doesn't matter, again, you can start with the pole or the basketball player, doesn't matter. I'm just going to start with the pole. So the height of the pole, I don't know, so I'm going to call it X. The shadow is 6 meters. Okay, and then the basketball player, we got to do that, or could be a girl, I don't know. Okay, the basketball player is 2 meters, so we have 2 meters for the height of the basketball player, and then we have 1.6 meters for the shadow. Okay, and after this, guess what, you guys? We cross multiply. So let's get going. So, and since we have decimals in this problem, decimals are kind of gross. So if you need to use a calculator, you can. In my opinion, decimals are the devil, but they do occur in the real world. So inevitably, when we do real world problems, decimals will appear. So if you need to use a calculator, I will allow you on these problems because we're dealing with the real world. Okay? So let's do X times 1.6, which I guess it doesn't matter. Okay, so X times 1.6 is 1.6X, and that will equal the other way. So 6 times 2. Okay, which 6 times 2 is 12. And all we gotta do is solve for X, which the 1.6 and the X are secretly multiplying. So how I move the 1.6 to the other side is by dividing it on both sides. So 1.6 divided by 1.6 will cancel. Okay, and we're left with X will equal 12 over 1.6, which again, since we have decimals, if you need to use a calculator, it's okay. So 12 divided by 1.6 will give me 7.5. So this will be 7.5. But I need to know what? 7.5 what? Okay, well, we're talking about the height of the pole, and everything in our problem was given to us in meters. So the pole is 7.5 meters tall. That's a really tall pole. And again, you guys, that's it. So just don't forget to include your units. And again, the hardest thing is setting it up. So if you got it set up, then you're good to go. Okay, let's get going on question 9.